Assalamualaikum and good morning to Dr. Zul and others that are watching this video. Today, my group, which is Group Kumon, will like to present to you our assignment video, which is Assignment Logic Circuit. This course code is Benr 1123 and our session is 2022-2023. My group may contain 5 group of members, which is me, and my name is Siti Nurwayu binti Kamardin. Next, Siti Khairunisa binti Abdul Rashid, Nur Ain Fakihah binti Mashlino, Nina Atika binti Nur, and finally Firza Farah Erina binti Muhammad Fazil. So I will continue with the truth table. This is the truth table that we got from the question. From this truth table, as you can see, either one of the 5 sensors to have input 1, or it can be more than one of the 5 sensor in order to get output 1, or it can be all of it input 1 and get the output 1. So that's all from me. Thank you.
Is Nur Ain Fakihah binti Mashino. Now I would like to explain about the De Morgan's theorem. So for the question says that to complete the digital circuit, you must use AND or inverter, NAND gates and LED to demonstrate the output. So in order to use all of these components, from both of the Carnot map, we will obtain that from the first Carnot map, the equation is M plus D plus S and plus L from 4 loops of 1. And from the second Carnot map, we obtain that D bar plus D. And then we simplify the equation from Carnot map, and we get the equation of the Carnot map, which is K plus M plus D plus S and plus L. So in order to do that, we must use the De Morgan's theorem, which is we are going to put 2 bars on top of the equation, which is K plus M plus D plus S and plus L. And then we are going to break the bar and change the operator. And then lastly, we are going to change again the operator, which is K multiple with M with bar, which is we are going to use the OR gates, and then change the operator for D plus S plus L with bar on top. And then lastly, we are going to put the bar on top of the equation, which is we are going to use the NAND gates. From the De Morgan's theorem I mentioned earlier, so this is the diagram of the circuits, which is we are going to use inverter, OR gate, NAND gates and AND gates, and also LED at the end. That's all from me. Thank you.
Hi, my name is Nina Atika binti Nur. Now I will show with you the simulation that we got from the truth table. Okay. From this, use AND gate to check if the key in the ignition is open. This will detect the driver is leaving the key in the ignition when the door is open. Then use an OR gate to check the seat belts are not bucked or the motor is running. This will detect the driver is driving without bucking their seat belts. Use a NAND gate to check if the lights are on and the key is not in the ignition. This will detect the driver has left the lights on when the key is not in the ignition. 10. Use an inverter to invert the output of the NAND gate from step 3. Use an OR gate to combine the output of the AND gate from step 1, the OR gate from step 2, and the inverter from step 4. This will give the final output signal that will control the alarm buzzer. Use an LED to display the output of the OR gate from step 5. The LED is on. It means that one of the conditions for activating the alarm has been met. The buzzer should be activated. This should give you a digital circuit that can detect the driver is leaving the key in the ignition when the door is open, driving without buckling their seatbelts, or leaving the lights on when the key not in the ignition. That's all from me. Thank you.
My name is Siti Karina Sabinti Abdul Rashid. I will explain about function of components. The first one is 4-bit adder. It will add two 4-bit numbers and give off a carry as the output. The next one is 4 to 1 multiplexer, which means that choosing a single binary bit from 1 to 4 inputs and sending it to single output. The third one is comparator. It will compare two 4-bit indicators and give the result output as A more than B, A equal to B, and A less than B. The last one is 3 to 8 decoder. Means that decode binary numbers to decimal number and activates only the output that correspond to that number.
Hi, my name is Firza Farah Erina, and now I will present about the calculation and output for question 2 part 1. Now the value of m and n here will be the input. Then we need to add this number and we will get 100001 for the answer. Now for the first component we have NAND gate here. So both input for NAND gate is 0, therefore we will get 1 as the output. For this we will get 1, 1, 0 and 1 for the others. So for comparator, we need to convert this binary number to decimal values and make a comparison to get the output. So for A we will get 11 and B 15. Since A is lesser than B, we are going to put 1 here and 0 for the rest. Okay, now next we have OR gate here. For the input, we have 1 and 0, thus the output will be 1. Then we're going to put 1 here and 0 at entry. And then convert them to decimal, so we will get 3 for the answer. Now we're going to put 1 here and 0 for the rest. For NAND gate here, the output is 1 since the input is 0. And for OR gate, the output is 0, and for the OR gate, the output will be 0 since both input is 0. Over here, we need to put 1, 0, 1. According to 4 to 1 multiplexer truth table, we will get 0 here. And the output for the inverter is 1. And here, 0, 1, 1. For this component, we need to convert them to hexadecimal, which is D. From the 7-segment display, B, C, D, E, G will switch on, thus the values for B, C, D, E, G will be 1. And the rest is 0. But for this part, we have an active flow, so that the 0 will be 1, 0 will be 1, and 1 will be 0. So this is the values for output pin, and the final output for number will be displayed in 7. Display is D, which is like this. Okay, next we're going to present for part 2 question 2. Now M and N here will be the input as usual, and then you will get the output like this. By following what we just did in question 1, this is how the output will be like. Unlike question 1, A is greater than B. So the output here will be 1 and the rest is 0. So we will get 1 here and the rest is 0. So convert to decimal, we will get 2. So we need to put 0 here and 1 for the rest. For this step, it's the same with question 1, which we need to refer to 4 to 1 multiplexer truth table. By converting this binary to hexadecimal, we will get C. So A, F, E, D will switch on, so the value for those will be 1 and the rest will be 0. Okay, so here we will see the final output for question 2 part 2. The values of output pin and also number will be displayed in 7 segment display is C.